Welcome guys. In this video, we are going to be covering IXL assignment 7-4Z, reflections over the X and Y axes, graph the image. So first off, if you look at the left there, you will see a little picture to kind of help you out with how to do those reflections. Because remember, when you do a reflection, it's like a mirror image. So it is very similar. We have corresponding parts, everything is symmetrical. The only difference is it's flipped. It's a mirror image. So for example, if I raise my right hand in a mirror, it's going to look like I'm raising the left. My hand is still raised. It's still in that, same location in regards to the rest of my body. The only difference is it looks like the opposite hand is raised. What that means in regards to math, because our focus is the X and the Y axis, is if we are reflecting something across the Y axis. When you do that, I'll make this line a little bit darker. When you reflect something vertically across that Y axis, your Y value stays the same, but you have the opposite X. So if your X was a positive number, it would become a negative. Or vice versa. If it was a negative number, it would become a positive. Now, if something is being reflected across the x-axis, so reflecting it horizontally, your x value stays the same, and it's just the y value then that has the opposite sign. So let's go through that, and we'll kind of discuss why that little rule works as we go through these examples here. So remember guys, we are on 7-4Z. We are told in this problem that we are supposed to graph the image. So in this case, the point L, which is located at -1, 3, after a reflection across the y-axis. And they have even highlighted that y-axis for you. That will be done for the first little bit of this assignment. Well, if we look back at our rule over here, when I reflect something across the y-axis, my x is opposite and my y stays the same. So currently, our point is located at -1, 3. When I reflect it and I apply this rule, my x value becomes the opposite. So I multiply it by a -1, and -1 times -1 would be a +1, and then your y value doesn't change. So right here would be the coordinates of your L prime. And for this assignment, we're asked to choose the point. So I'm going to come over to the point 1, 3 and click it. Now that I've done that, let's kind of look at our graph here. This is a good way to double check your work, or maybe you'll find you like this method better and you'd rather, do your problems this way. Notice that that line of reflection is like a line of symmetry. It splits it in half. So point L is only one space away from your y-axis, and it stays at that same value for y. It stays at that same level, but once it's reflected, it now goes to the opposite side and is still one distance away from that reflection line. That right there is why our rule works, because when we reflect it, the y value stays the same. It's just now flipped on the other side, which is why your x value became positive. All right, let's try this one out. So this time we are having to graph the image D, which is located at 2, -3. And we are once again reflecting it over the y-axis. So currently our pre-image is located at 2, -3. And if we're reflecting it across the y-axis, that means we're using this rule. Our x has the opposite sign, but our y value stays the same because it's being reflected across the y. When we apply that rule, 2 times -1, or the opposite of a +2, would give us a -2, and then your y value stays the same, which means it stays at -3. That right there would be your answer. Let's double check this using that graphing rule, or that graphing little, cheat, so to speak, when you have a graph on how to reflect it. So we see right here, D is 1, 2 units away from our y-axis. It's 2 units away from that line of reflection. Therefore, when I reflect it, it's going to be an equal amount, an equal distance away, which would be 1, 2 away, leaving us with this point, which, oh, looky there, it happens to be -2, -3. Pretty cool, right? All right, let's bump it up a notch here. Once you get through the first couple questions, you are going to start having to reflect shapes. The only difference here is that means you do have to reflect all of the vertices, all of your points, whether it be 2 points or 3 points, okay? So we're going to do this one using both methods. I'm going to kind of teach each question here using both methods so you guys can see each one, and then you get to choose whichever method you would prefer to do the problems on your own. But it is nice to see both. First off, we need to read the problem to see how we're reflecting it. It is being reflected across the x-axis. So I'm going to go ahead and I'm going to do points N and K using that graphing method. So that graphing method is where we are just counting the distance, and then we're moving that same equidistant amount on the other side of our x-axis. So point N is 1, 2 away from our x-axis. Therefore, when I go to the other side, I would also need to be 1, 2 points away for our N prime. And then K is 1, 2, 3 units away from our line of reflection, our x-axis. So when I reflect it, when I flip it on the other side, it's going to stay in line, but it's also going to be 1, 2, 3 units away. Now for M and L, let's use our rule. Let's use what you would do if you didn't have a graph. In order to do that, we need to know where those points currently are located. So M is currently located at 5, -2. So in order for me to get the points of M prime, since I am reflecting it across the y-axis, that means our x value stays the same and we have the opposite y. So we multiply that y by a negative number. All right, x stays the same, x would be 5, and then our y is the opposite. The opposite of a -2 would be a +2. So M prime would be located right here at 5, 2. And last but not least, point L is currently located at 5, -3. If we do this one using the rule to get L prime, it's reflected across the x-axis, so our x value stays the same at 5, and then our y value becomes the opposite. A -3 becomes a +3. Oops. And looky there, I was just going to make a comment, guys, that you can know that you did it correctly by seeing if it still really makes a rectangle. And looky there, I noticed that, oh, my L is up a bit too high. I misread my graph there. I put it at 5, 4, but it really should be right here at 5, 3. And if I compare my two shapes, get my laser pointer here, we notice that it's 1 by 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a 1 by 9 in regards to its area. And this one matches 1 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can always take that time to double check your work. And of course, once you graph it on IXL like I just did, let me clear this, you can see that it is beautiful. It just is reflected up. It's just right up there, only flipped to the other side of the x-axis. All right, let's do one more together. This time we have a triangle LMN and it's reflected over the y-axis. So I've gotten high enough that it no longer highlights the axis for me. Make sure that you're reading carefully. We are reflecting it across the y-axis here. We'll do like we did earlier. We'll do a couple points with the graphing method and a couple points using the algebraic method. So just applying the rule. Let's do point M with the graphing method. I notice that M, if I'm reflecting it across the y-axis, that's where I'm counting to, that's my line of reflection, is 1, 2, 3, 4, 5, 6, 7, 8 units away. So if I reflect it, it's going to go 8 units away on the other side. 1, 2, 3, 4, 5, 6, 7, 8. Right here would be the location of our M prime. Let's also do N that way. N is located 1, 2, 3, 4, 5, 6, 7 units away. Reflected across the y-axis. We're going to go 1, 2, 3, 4, 5, 6, 7 units away. Looky there. And for point L, we're going to use our rule. We're going to work it out algebraically. In order to do that, we need to know its pre-image coordinates. L is located at -8, -6. Because we're reflecting that across the y-axis, our rule is we have the same y, but the opposite x. When I reflect to get L prime, the x becomes the opposite, so a -8 becomes a +8, and your y value stays the same at -6. Which would be right here. I'm going to graph these and then we can look at them to kind of make sure that everything does make sense. It does, because when you reflect something, it flips it. So I can see that my triangle here, it's a skinny one, but it has been flipped. It has been reflected across the y-axis. All right, it is your guys' turn to try this out. You can use either method, whichever one worked for you. Do also remember that if you would like an example in another voice, or you would just like another example period, IXL has tutorials built in for you. Those videos are awesome. You can use that as an additional resource as well. And of course, if you need anything, just send an email or come to a help session. Bye, guys.